Hello friends, welcome back to my channel. In this video, I will explain you how we can measure the length with the rotary encoder in Siemens PLC S7-200. But before start this video, please like, share and subscribe this channel. This way you will be never miss my upcoming videos. So let's get started. First of all, I will open my step 7 microwin software and next we will check the communications. Double click it on the refresh. After, if your PLC is connected with your PC, that will be shown address and everything will be shown it here, and click it OK. And next we have to be configure our encoder first. In previous video already I explained about how we can configure, but again I will show you. Go to the wizards and here high speed counter choose, and these settings will be appear, and which counter you like to be choose you can select it from here. I will choose this mode 4 and click it next, again click it next, and again click it next. After finish, your configuration will be completed. And next you will be choose it here one input address, and next you can be choose from the call subroutine functions your first high speed encoder, and here internal bit you can give SM0.1, and second you have to be choose any data register where you like to be move your value. For example, this one also I will take SM0.1, and in second step we will choose the move command, and you can go here the increment move, this is move DWD, and here HC0 we will choose, and next VD20 for example we will choose, and our encoder setup is completed. And next our lecture is what how we can measure the length. For an example, first I will download this chapter and we will clear our countings. Our encoder is working properly or not. After we will design the program for length measuring by the encoder. Make the status on, and as per seen, this one mistake we made. This is SM0. Same address we give, we have to be given 0.0 and 0.1 because of two signals we are using from the rotary encoder, I0.0 and I0.1. It's very simple and easy procedure. You can easily read your value at the PC. Now I will increase my length. I will move my encoder. You can see now value is increasing. And for example, this value is coming now, but how we can measure the length? This value is basically coming in bits only. This encoder when moves behind the motor or somewhere or gearbox, when you fix this encoder, after you can see when motor runs, after your encoder will be also moves. When encoder moves, after you can see this value is generating in the PLC and at this data register. After this value, for an example, your length is for example 300 mm or 500 mm, and when you manually make it on the motor, and after your length total length which is you designed in your program, design in your hardware, this total bits generated for example 2000. For example, this I make it this 2000. Now your motor is totally at the pinpoint and your lengths are finished, and this total bits achieved 2000. So what formula we will use in the PLC? For example, I will take it here calculator. This 2000 bits for example divide by you can have to be divide with your original length. For example, this is 200 mm, means this is your area, or 500 mm for example. This total bits you can divide by 500. If your length is 500, you can divide by 500. After, you can see the answer is how much? 4. What's your formula works, Jani? Means 4 bits are equal with your 1 mm. Total length is your 500 mm and total bits are 2000, and your 1 mm is equal with 4 bits. So this formula we will apply in our program. How can apply this formula? We will use it here, the division command. When you go stop the program and go in the integer math, and here you can see the division. You can see this division command here. First you can put any close contact, for example I0.2, an example I will choose, and here you can choose VD, for example 20, VD 20 when, and how much formula we decided here? 4 bits, yani. You can put also here data register. If you like to be set point, make changes from the HMI, you can put any data register. For example VD25 I will choose. After, I will put the value at the VD25 and take it any data register. VD, for example 30 I will choose and click enter. Now our value will be this VD20 here, divide by this 4. After, answer will be reach at the VD30. So VD30, what we will do, we will take it here. For example, close contact of the uh, not yet close contact, we will take the direct it here, compare section. Go to the compare section, and you can take it here, equal or greater than command. Equal or greater than command, you can take it here, VD30 for example equal with this, also VD40 we can choose. Because of this setting, no need to be again download. We have to be one time now download the program. After, we will make the set point at VD40 and VD25. Here we have to be put our dividation, which is our formula value, and here we can put which we have to be decide for your start and stop, any relay output you like to be start and stop. So here we can put the relay. For example, here I choose internal memory bit M0.0, for example I will choose. So in next row I will choose the close contact of the M0.0, I will choose, and I will make it on and off my Q0.0, an example. Any you can really choose. And this program now we will download to the PLC, and let's see the result. Our program is 100% okay, 0 error, 0 warning, and 100% downloaded to the PLC, and click it OK and make the status on. And now you can see this VD25 we decide for our formula. For example, that's 4 bits we decide for, yani 500 mm length. So 4 we will decide it here, and this value how much length after we like to be stop, yani for example I will put 500 because of we make this length for 500 mm after our Q0.0 will be off. Now it's immediately why on, because of I use the close contact of the M0.0. And now we will increase our encoder value. Now you can see I am increasing the value of my encoder. So 500, 600. Now you can see at the VD30, at the VD30 your original MMS are coming. As your value will be reached at the 500, 500 mm, 450, 60, 70, 80, and you can see 500 mm after your Y0 is now, your Q0.0 is now off. Because of your length is completed here 500 mm, we decided it here 500 mm. And bits we decide 2000 bits we make for yani uh, for 500 mm. When your motor travels at the 2000 bits, after your mm will be 501. And for example, if you choose another formula, this VD25, you can take it the HMI and how much calculation you made for your length of the and encoder value. This also VD20 also you can take out the at the HMI, and you can see the status of your VD20, and after you can make the set point from the VD25, and your original mm will be displayed at your VD40. Sorry, VD40 will be set point, and original your set point will be shown on at VD30, where you can make the set point how much coming your mm, this you can use. So again I will reduce the value. Now this is increasing, and you can see now this will be closed because of now it's at the 478 mm. 440, 20. If you increase again, after you can see as your 500 mm will be completed, at the pinpoint 500 mm will be stop your Q0.0, and that will be decrease after your Q0.0 will be on. That Q0.0 is will be your motor which is connected with your encoder. When your motor moves and achieve your travel distance, after this will be start and stop. So hope guys you will be understand about this program. If not understand anything, you can send me the message in comment section. I will give you feedback as soon as possible. So thanks for watching. Allah Hafiz.